Chapter 4 is dealing with transformation. So make sure you write that word down, or look at it here. Transformation. It's on page 94 of your student journal. Transformation. This is one we'll talk about. A transformation takes an original shape, which we call our preimage. It takes our preimage and it changes it in some way. By moving it to a different location, by rotating it, translating it, reflecting it, or changing its size by dilation. Okay, so there are different transformations that we're going to study. The one that students sometimes confuse is the word translation and transformation, because they both start with trans. A translation, the slang term for that is a slide. That is one type of transformation. Another type of transformation is a rotation. Anyone know the slang term for that? That is called a turn. Well done. Okay, and reflection. Reflection, we call a flip. Flip, slides, turn. Sam? There is a dilation. Yes. Dilation. Dilation is changing its size and shape. So it's like the best example is what you're looking at right now, the projector. It's taking something from under my camera and it's projecting it onto the big screen for you. That's a dilation. It's changing its size but not its shape. I think I just said changing its size and shape. It's changing its size but not its shape. The figure still has similar proportion or similar side lengths. Okay, the similarity ratio is the same. Okay, sides are proportional. So we'll talk about that a little later. That'll be the last one we talk about. Okay, an image. An image is the figure. It's our new figure. Okay, it's the figure after you've done a flip, slide, or turn. The preimage is the beginning figure, or the beginning shape, depending on what you're using. Usually they're going to be shapes. Sometimes they'll put maybe a little zigzag line and have you move that. But the beginning figure and the new figure. So our preimage to image. Translation we've already described. Okay? And the last one I want to go through, and the rest of these you can figure out or fill out, as we go. But the last one I want to just touch on before we start is a composition of transformations. That means multiple transformations. It means you're doing multiple things to it. So maybe you're sliding it and then reflecting it. Okay? So an example would be like a glide reflection. It's where you slide and then reflect. Yeah. Yeah, you do it to one. So maybe you take the letter L and you slide it over to here. And then if we put a line here, that's a poor line. Thank you. Put a line there and then you reflect it over. Okay, that would be a composition. Okay? Yeah. The artwork, I know. Not amazing, but that's okay. Yes, Ian? No, it could be more than two. Yeah, it could be more than two. It just has to be more than one there. Okay. All right. Very good. Any other questions? All right. So let's go ahead and take a look at this page. You'll notice on this page, I just want you to read down through it. And you're going to see some of those other vocab terms you may want to define as you go. But go ahead and read through the core concepts on the top here. It's page 95 about vectors and translations. Then we'll discuss them. Okay, so before I go through discussing those with you, I want you to try those three problems on the bottom of the page. Okay, let's use pencil. See how well you understood what you just read there. Okay? Okay, let's see how we did. Name the vector. So, you guys, vector notation, when we write out the name of the vector, we put a little line above it. It's array, so we're going vector mn. All right? And when we're actually using component form to write that out, we're saying we are moving. We're moving along the x, or horizontally, that far. So how far is that? What's that? That's 4. And we're moving upward how far? 6. Okay? So we would say we're taking that and we're moving it x plus 4 and y plus 6. That's how far we're moving it. X plus 4 and y plus 6. Now show your neighbor what you put. Before I answer the questions of the hands that were up, for those of you that put, I'm assuming the question is, what if we just put 4, 6? Or is that the question? Okay. So if you just put 4, 6, really, yeah, you're saying, yeah, I moved at 4 and I'm moving at 6. I'm just saying that if we know this value, we're going to add 4 to it and we're going to add 6. This would be a fine answer for what we're doing here. Okay? I was just pointing out that from x, or on the x-axis, we're adding 4, and the y-axis, we're adding 6. But you're moving at a vector of 4, 6. So this answer right here is just fine. Okay?
It says that you have to write vector and then would you just do what you did? Just write array and then?
Yeah. Yeah. And it's kind of hard to see up here. At least in your book. I thought it was kind of hard to see. Okay? But they're talking about these different I still didn't get that in there. There we go. They're talking about this distance here. Well, that distance is a ray, so we're going to write it with a ray symbol. Now on here they show it as a line. Component form of that line, PQ, is 5, 3. Okay? And that's the same thing as saying, hey, I'm adding 5 to my x and 3 to my y. So if you actually know your x and y value, you would have to add those to get that. Yeah, Cynthia. Yeah, that's called vector notation rather than ordered pair notation. Okay, so you don't get it confused with an ordered pair. That's a good question. You're not moving to the coordinate 5, 3. You're moving 5 and then 3. Okay? You're moving the vector 5, 3. Yeah, Drew?
Will you ever use these like with not like actually in a certain case for the problems?
If you're discussing how far a vector moves, you're going to use these.
I know, but like in one equation, like if we're doing like a problem where we need a vector.
Well, let's try some of them first, and then maybe we'll see if we're getting to what you're talking about. All right, what's happening on this one? This time we're going from B to A. Okay, how far are we moving horizontally? 5 units left. So that is -5 and down 1. Okay? So from K to J, KJ. Nice. No JK. All right? We're moving to the left. How far?
5.
Moving left 5 and up 3.
You have to do that.
Like in that order.
Up 3 and then over 5.
You can, but the up 3 is your Y change, so you got to put it in the Y position. Okay. How many got it? All right, any questions? All right, let's turn the page. Check out page 2. It's actually page 96, but page 96. Take a look at the top part. Now, I gave you some different grids just because it's easier to write these on. They should be front and back, so I gave you grids like this to do these. Okay, so what I'd like you to do is I'd like you to take this triangle, plot it on a grid, and then you're going to move it this far. Okay? Take this triangle, plot it on a grid, and move it that distance. And then take that triangle, plot it on another grid, and move it that distance. So this will be problem 4, problem 5, and so on. Okay? The reason why I'm not having you do them all in here because it gets really messy at the end because you have 4 different triangles. Well, 5 if you include the pre-image. So this is your pre-image. All right? Give it a go. All right, so we're going back 4 units on the x-axis. So 1, 2, 3, 4. 1, 2, 3, and 4. 2, 3, and 4. All right, so my new figure is right there. Now, probably not the best thing to use a highlighter on, but that's what I've got. And what we're going to do is we're going to label these points. This vertex would be called A prime. We put a little mark above it. This one would, that would be C prime, not A prime, because it was that point. This is the sliding of A, so we call that one A prime, and this one would be B prime. All right, so maybe a better picture. Yes, Sam? So this is saying I'm moving 4 units to the left on the x-axis. And this is saying I'm moving no units up or down. So from my original point C, I'd move 4 units. 1, 2, 3, 4, and that's my new point. It's always from your original. Yeah, from your pre-image. So point B, we'd also have to move this one 4 units. And then this one 4 units. Yeah, Alex?
So, what's the prime symbol?
The prime symbol is just this little mark above it. So A prime would look like that. We'd just have a little tick mark up there. Okay? A prime, B prime, C prime. So we call that triangle A prime, B prime, C prime. No relation to Optimus. Got number 5 up there as well. From your original, you go back 2 and down 4. So some students, it helps them to actually show the little vectors. So you go back 2 and then down 4, and that shows you your new point. Back 2 and down 4. Some students, that really confuses them. They're like, man, that's too many lines. Okay, but this says I'm going to left 2 and down 4 units. All right, so I'll leave that blue one there because I can't erase it. I'll erase those. All right, I'll be walking around. Ask me questions. You got them for those other 2. Hey, a good question came up. You know, do we call all of these A prime, B prime, C prime? Well, since they're all on different grids, yeah, you call them all A prime, B prime, C prime. Now, if we had put all these on the same grid, the first one we call A prime, B prime, C prime. The second one would be A double prime. So you'd have 2 tick marks, B double prime, and then C double prime. So if you do more than one transformation on a grid, then you'd want to mark it accordingly. So the first one would be 1 prime, second one would be 2, and then 3, and so on. Yeah?
So the original isn't prime, but then we change it?
Correct. The prime tells us it's a transformation of the original. So your pre-image is not prime. Your images are prime. Okay? So it's just a notation you want to get used to. Anyway, those are your transformations. All right? So given 4, 5, and 6, On 7, I can almost get them all up there. Okay. Lexus. Just stretching. Flexing. Do that too sometimes. All right. Made it rhyme. Moochie, you're a poet and you didn't know it, dude. All right. Number 8. Maybe you did know it, actually. 8 and 9. Give them a go. Write a rule for the translation of the quadrilateral to the prime quadrilateral. Wait, what? Sounds like a song. Wait, what? Wait. You can make it into music, man. Just start singing. Yeah, I am colorblind. Are you making fun of me? Are you? Am I like dressed weird or something?
No.
All right, here we go. I do. Thank you. All right, so you guys, a rule, when we're writing a rule, that's kind of what I did at the very beginning when I used the pluses. So I am taking all of my x values. So if I had the ordered pair x, y, like each one of these coordinates of our preimage has an ordered pair. When we're writing a rule for the translation, we're saying that we're going to take all of our x values and we are going to add, how much are we adding? To get from q to q prime, we have to add 1, 2, 3, and 4. So you go over 4 units. And then we take all of our y values and we move them up 3 units. That is our rule. So we're saying x plus 4 and y plus 3. That's what's happening. You don't have to put those in the vectors. I think I put them in vectors originally. You'd actually have it in ordered pair. Yeah. Okay? Yes, sir? Yep, when you're writing the rule. Yeah. Okay? All right, so what's the rule on number 9? Good. X plus 1. Okay, we're adding 1. Because they're cool. Once again, did you look up that word I asked you to look up?
What word?
Tact. You gotta look it up again. X plus 1, y minus 3. Okay. All right. Questions? Okay. Now that you know that, I want you to try number 10 and 11. Tact.
Wait, what does it mean? No, so being sensitive, we're talking about feeling like the same thing. Being sensitive. How is that related to?
All right. We can talk about it here in a minute. Hey, guys, this is saying if I have the ordered pair x, y, I'm going to add 6 to x. That is 4 plus 6. And I am taking away 3 from y, which gives me 10, 2. That's my new point. That is the image. That's that point after you move it. Yep. The image, remember, the image is the figure after you do something to it, after you transform it in some way. Okay, so what is the image of r prime? In other words, where is that point? Okay. Now remember, hey, this is the image. What is the image of r prime? Okay, go ahead and figure it out. Tell your neighbor what you get. What'd you get? Yeah. Oh, okay. Yeah.
6, -8.
6, -8. How many got 6, -8? Okay, so everyone added 6, and then they subtracted 3. 6, -8. Anyone get something different? Okay. R prime prime then, right? That'd be R prime prime. Because R prime was that. This would be R double prime. This would be J prime. Okay. Last one. I'm going to hand out your assignment while you guys are working through number 12. Okay? Do your best.
I've been trying to.
All right, in a video game, you move your spaceship 1 unit to the left and 4 units up. How could we write that as a vector? -1, 4. Okay? You then move your spaceship 2 units left. How do we write that as a vector? -2, 0. Rewrite the composition. Well, you just add your vectors. -3, 4.
It's the 4th. November the 4th.
There we go. So you guys, so if you go back 1 and then up 4, that brings you to here, which is hard to see on there. Okay? And then you go back another 2. Okay, that's going to bring you to right there. All right, that's the same thing as going back 3 and up 4. All right? So when you're doing a composition of translations, you just add them up. All right, you have your assignment. Do your best. I'll be handing out your test.